Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 4.2.3, which is a look at inverse trigonometry. And so, in problem 4-78, we're talking about Mr. Gao and how he needs to build a wheelchair access ramp for the school's auditorium. The ramp must rise a total of 3 feet to get from the ground to the entrance of the building, and in order to follow the state's building code, the angle formed by the ramp cannot exceed 4.76 degrees. So right now, Mr. Gao has plans to build the ramp 25 feet away from the building. Now, we're supposed to answer the question, will the ramp meet the building code? And so we're going to draw an appropriate diagram for A. So from here, we know that Mr. Gao wants to make the ramp 25 feet away from the building, and we know he has to have a 3-foot rise in that ramp. And so what we're looking for is we're looking for the angle that creates a slope ratio of 3/25. So as you are probably gathering, and I hope you are, the notion of inverse trigonometry allows us to solve for angles rather than regular trigonometry where we input the angle and then we output a side ratio. In these situations, we will be given the side ratio, and now we will need to use inverse trigonometry in order to find the angle that created the sides. So, in B, it says to determine an angle measured from a trigonometric ratio, you need to undo it like you do addition with subtraction, like the way you undo multiplication with division or squaring by taking the square roots. These are all inverse operations. So, what they're trying to tell you in this next section here is that the inverse operation of sine is something, it looks like sine to the -1 power, but it's read as sine inverse. Just like cos, what looks like to the -1 power, is really cosine inverse. And then tangent inverse is just that, it's tangent inverse. And so what they want you to do is they want you to verify that the cos inverse of 8/16, do you actually get 60 degrees? You do. And so the way you access the cos inverse button on the calculators is usually second cosine. And so you will get 60 degrees when you invert the 8/16. And why is that? Well, that's because, remember, if you do cosine of 60 degrees, you get 1/2. If you do the opposite operation to the 1/2, you're going to get 60 degrees. We'll summarize this at the end of the lesson and how trig inverses work alongside their trig counterparts. We have to return to the diagram from part A. What angle will the ramp make with the ground, and will the ramp beat a code? Well, let's take a look. I'm going to go ahead and say tangent of theta, this is the angle, is going to equal 3/25. Now, whether you realize it or not, we actually have an equation here. And the way I'm going to get rid of the tangent that is surrounding the theta, and everyone makes this mistake, I'm not going to divide by tan, because this is not tangent times theta, it's tangent of theta. So the way I get rid of the tangent is I have to tan inverse both sides, because tan inverse and tangent are inverse operations of each other. These guys will cancel, and I have theta equaling tangent inverse of 3/25. In other words, the side ratio of 3/25, when I take tan inverse of it, I will get an angle that is the ramp's angle. That's going to be 6.84 degrees. So clearly this is not to building code, and Mr. Gao has not been able to make the appropriate ramp. In part D, it says at least how far from the building must the ramp be in order to meet the building code. And if he wants it exactly the code, how long will the ramp be? Show all work. In order to answer this question, what I'm going to do is I'm going to start off with the angle that we need. So we know that the angle needs to be 4.76 degrees. So this needs to be 4.76 degrees. We know that it has to rise a total of 3 feet, but we don't know how far away it needs to be. So again, I'm going to go back to regular tangent now. So the purpose of this problem here is to show you the difference between regular tangent and tan inverse. I am no longer solving for an angle, which means since I'm solving for a side on a right triangle, I'll use regular tangent. So I'll say tangent of 4.76 is equal to 3 over x. And now we're hearkening back to chapter 3. So from here I get x times tangent of 4.76 is equal to 3. Divide both sides by tangent of 4.76. And I get x equals 3 over tangent of 4.76. And that ends up becoming 37.5 feet if I round to the nearest first decimal. And so from here, that's how long away the ramp has to be in order to meet the state building code of 4.76 degrees of an incline. Okay, so let's go and move on to the next problem. Give me a second. I'll post it on here, and then we'll summarize inverse trig. In this next problem, it says, for the triangle at the right, determine the measures of angles A and B. Once you have solved for the measure of the first angle, what knowledge about angles and triangles can you use to help solve for the second angle measure? Okay, so in this one, notice how they're asking me to solve for an angle now. What did we just learn? We just learned that inverse trig functions allow us to solve for measures of angles. So I'm going to go ahead and choose an arbitrary angle. I'll just choose A, and just to keep things alphabetical. And then from there, I think you all know what we're going to do to solve for the second angle here. And so from here, this is 14 and this is 15. I'm going to go and arbitrarily call that angle theta. And so what I'm going to do is I'm going to say, all right, I've got an angle theta, and from this theta's perspective, I'm going to have an adjacent side and a hypotenuse. Well, angle, adjacent, hypotenuse sounds like cosine. So the way I set up the equation, it's going to be cosine of theta is equal to 14 over 15. So this is the equation, whether you believe it or not. It's the equation. I'm going to solve for theta. How do I do that? I'm not going to divide both sides by cosine because it's not cosine times theta. It's cosine of theta, like we talked about up there. And so in order to get rid of the cosine, I'm going to inverse cosine on either side. And I get theta equaling cosine inverse of 14 over 15. And when I'm finished calculating that, I'm going to get 21.04 degrees. And so with this guy being 21.04, now I can go ahead and use my triangle angle sum theorem to say that this guy is going to be 180 minus 21.04 minus another 90, which ends up making him 68.96 degrees. So again, the whole point of this is knowing how to use your trig functions to solve for angles. I'll be back with the next problem. And in 4-80, we are going to look at every single one of these triangles, and we're going to figure out what the angle is that created that side ratio by using our inverse trig ratios here. And so from here, what I'm going to do is I'm going to go ahead and say, all right, well, if I do this angle, I've got an adjacent side and a hypotenuse. So I'm going to go and say, all right, since it's adjacent over hypotenuse, that's automatically cosine, right? Cosine of that angle, whatever that angle is going to be 12 over 24. Well, I can go and reduce that and say cosine theta is equal to 1/2. And I could do cos inverse on either side if I'm really going to stick to the calculator on this one. And what I'll get is I'll get theta equals 60. Now, we should have known that from the beginning because we've seen this 60 show up before, creating a delta x over hypotenuse or adjacent over hypotenuse relationship of 1/2. If you didn't see that, don't worry about it. The calculator will give you 60 regardless. Same thing here with B. If I really wanted to stick to the literal definition of solving for an angle, I could say that tangent of that theta, and I used tangent because I have an opposite side and an adjacent side, is equal to 8 over 8, which reduces to 1. So we've seen this ratio multiple times. At this point, theta equals 45. Again, there it goes. That slope angle of 45 creates that slope ratio of 1 over 1. And so you could have used a calculator on this one. If you did, you would get theta equals tan inverse of 1, which ends up getting you 45 anyway. The one that isn't clear is C. And that is because we don't have anything readily known for 57 degrees, but we do know that from the 57 degrees perspective, we know that 7 over x is going to be opposite over hypotenuse. So because this time I'm going to be solving for a side and not an angle, I'm not going to be using an inverse trig function. I'm going to be using a regular trig function. So the trig function that relates angle opposite hypotenuse is going to be sine. So sine of 57 is equal to opposite over hypotenuse. I'm going to go and get x by itself. So I get x times sine of 57 is equal to 7. Divide both sides by sine of 57, and I get x equals 7 over sine of 57. So I do want to summarize this real quick before we call it a lesson. And that is, I want to separate this out into normal trig functions and inverse trig functions. So normal trig functions and inverse trig functions. And so I want to separate these out a lot. That way we are very clear on what's going on. Okay, so in a normal trig function, I'm going to go ahead and get sine of a thing equaling something, cosine of a thing equaling something, and tangent of a thing equaling something. And so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, all three of these things, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, they all refer to one thing. These are side ratios of a right triangle. Right? These are all side ratios of a right triangle. And these are the outputs of the normal trig function. What goes inside each time, what goes inside is always the angle. The angle is the input. Okay, the angle is the input. The side ratio is the output. Okay, inverse trig. Let's take a look at that. From here, I'm going to go ahead and put them down. Sine inverse of a thing. Cos inverse of a thing. Tan inverse of a thing. What do those get me? Well, remember, inside the sine inverse will go the opposite over hypotenuse. Inside the cos inverse will be the adjacent over the hypotenuse. And inside the tan inverse is going to be the opposite over adjacent. And every single time you output, your output will always be an angle. Your input is the side ratio. And that is the notion, that is your first small exposure to what we call the inverse function. And the inverse function, and I'll even type this out for you guys, this inverse function, right now I'll give you guys a more basic definition of it, but we will get more complicated with it as we end the class and as you move on to integrated 3. The inverse function, at its core, what it does is it takes the role of the input and output and reverses them. So it takes the role of the input and the output and reverses them. And we see that happening here, where we used to put in the angle, and then we got out the ratio of sides for the normal. And then for the inverse, we input the side ratio and output the angle. So hope you all found this useful. As always, please leave comments or questions in the comments area, and I will see you all in the next episode.